So our focus on this problem is going to kind of take a function that's given, ultimately a parent function that's had some transformations applied to it, shifting, etc. Identifying what that parent function is, knowing what the basic graph should look like, describing how all of the number adjustments affect the graph, which would be describing the transformations, trying to write this in a pre-calc form, looking at function notation, and then ultimately sketching a graph. Okay, so it sounds like a lot, but we're going to kind of break it down into chunks to make it a little more manageable. So our first thing is to identify the parent function. So I see absolute value as that base function. Parent is basically thinking about parents and children. The parent function is what the basic shape is going to be based on. So absolute value of x is the parent function. The absolute value of x, remember, is basically y equal x and all negative values. So we have y equal x, but it's been reflected up because all values of absolute value of x are going to be positive. So it's reflected vertically, or from the third quadrant to the second quadrant, to account for the fact that you can't have negative values. Okay, now describing the transformations, we're going to think about order of operations. And if you did not go through the exploration part of this or haven't taken notes previously, then this may be a little bit of a struggle. I'd go back and look at those things because I'm going to hit this part pretty quickly. Describing the transformations, when I've replaced the x with x plus 3, I'm thinking about from inside out, thinking about order of operations. So as we do this, the order does matter. Okay, so I'm going to say x plus 3 is going to make this shift left 3. The next thing, it's been multiplied by a negative 2. That negative 2 has two impacts. Number one, it's a vertical stretch by a factor of 2. The second thing it does is reflect it vertically. So reflect basically over the x-axis. And then finally, this negative 4 down the end, thinking about order of operations, shifts it down 4. Now the order is really important because reflecting over the x-axis and then shifting down 4 will give you a different result than shifting down 4 and then reflecting. So order is very important, and you think about order of operations working from the inside out in order to complete this. Now the next part is function notation. This is probably the most abstract part. It's honestly very simple, but a lot of people have confusion with it. We're writing it in terms of p. So instead of writing the absolute value, we replace the absolute value part with p of x. So we took basically function f, and we want to write it in terms of function p. Well, we took negative 2 times the absolute value function, and the absolute value function is p of x. So we took negative 2 times that absolute value function. We subtracted 4 from it. Now, it wasn't just p of x, it was p of x plus 3. The x plus 3 is in place of the x in the absolute value. So that is a function notation. We'll keep practicing with that. Now, quick sketch. I'm going to think about the normal absolute value function. I'm going to think left 3. So my vertex is moved left 3. Vertical stretch by factor of 2. We'll get to that here in just a minute. That one's kind of hard to do. It's going to reflect, it's going to open downward, and it's going to be shifted down 4. So I'm going to get that vertical or shift in there as well. So there's my vertical, or my vertex. It's going to be concave downward. So this thing is going to be opening downward. All right, and I'm just going to kind of sketch that in for just a second. We'll get some more accuracy here. So in order to tell this stretch by a factor of 2, I'm actually going to very quickly fill in a value. So if I took x and f of x, and I filled in like negative 2, a non-vertex value, I'd have negative 2 times the absolute value of negative 2 plus 3 minus 4, and I get negative 2 times the absolute value of 1 That's negative 2 times 1, which is negative 2 minus 4 is negative 6. So I fill in negative 2. I get negative 6, 1, 2, 3, 4, 5, 6, negative 2, negative 6. I actually had a pretty decent graph, and I get something like that. And keep in mind it's symmetric with respect to this vertex. So there's a quick sketch of that graph. Our next example deals with function g of x. I've just chosen a different parent function. In this case, I see square root of x. So p of x equals square root of x. That basic function looks like this. Starts at 0, 0, square root of 0, 0, square root of 1 is 1, square root of 4 is 2, so it looks kind of like this. Okay, square root of 9 is 3, climbs very slowly, top half of a sideways parabola. If I know that basic shape, we're just going to transform it. So, working from the inside out, if I filled in a number for x, I'd need to add 1 to it. That's going to shift it left 1. Then I would take square root, which is going to give us a shape. Then I would take it times 4, which is not going to reflect it because it's not negative. It's going to be a vertical stretch. Since it's times 4, it's going to be a stretch. If it had been like a half, it'd be a shrink. Vertical stretch by factor of 4. Okay? And then the plus 3 out on the end is going to be up 3. Okay? If I write that in function notation, I'm going to say, well, my original f of x is 4 times my function p plus a 3, and the p of x, the x has been replaced with x plus 1. So instead of p of x, it's p of x plus 1. Okay? We'll keep working with that. All right, so quick sketch. I'm going to think about that vertex at 0, 0. It's going to move left 1 and up 3. So I'm going to go left 1, up 3. So there's my new vertex. I'm not reflecting this vertically, so it's still going to have this same basic shape that we had before. Okay, vertical stretch by factor of 4 means it's going to go up a little steeper than that one. Okay, in order to get that, I'm going to fill in a number like 0. Okay, if I fill in 0, I'll have to this function right here, 0 plus 1 is 1, square root of 1 is 1, 4 times that 1 is 4, plus 3 is 7. Okay, if you need to see that, then put that on your paper so you can see that value. So we went up 3 from there, 4, 5, 6, 7. I fill in 0, I get 7. So this guy's a really steep version of that graph. Looks something like that, and we're finished.